So today we are talking about trinomials and cubics, okay? So first off, so far we already know how to factor. We always start with what? GCF. So anytime we see a problem and we are factoring, that is the first thing. Okay? The next thing that we have learned already, it deals with a subtraction sign and two squares. What do we call that? We just talked about it. Difference of squares, write that out. Or you could put DOS, I don't care. Difference of squares. Okay. The next thing that we're going to talk about. Okay. It says that we've already learned this. However, we skipped it last class. So this is something that we're going to be learning today. It's called the X method. And just go ahead and draw an arrow down here because that's what we're going to be learning today. We will learn the X method, which is what we call trinomials. The fourth thing we did learn, though, it had four terms. Anybody remember what that's called? If it had four terms. Starts with a G. GR. Grouping. Good. Grouping. Ow. Okay, that's when we have four terms. The other two things we're going to learn today, besides the X method, we are learning the X method today. We are also going to learn sum of cubes and difference of cubes. We've already learned difference of squares. Do you think difference of cubes is going to be similar? Yeah, it is. Okay. So, pre-steps to learning the X method. What the X method is. It is drawing an X, okay? And what's important to know about this X is that the two numbers need to multiply to make the top number, and they need to add to make the bottom number. Okay? So if you need a little visual, one thing I told the last class to draw is draw your X and put M here and A here. M-A, ma, okay? So you remember that the top number is multiplication, bottom number, addition. You with me? Okay. So draw that little visual. Now we're going to look at number one. I need two numbers that are going to multiply to give me negative 10 and that are going to add to give me 3. Negative 2 and 5. Good. Carter was quick on the draw on that one. Okay? Sometimes these are not going to be so easy just to look at and know. You're going to have to do a little guess and check with your calculator. Okay? Like, for instance, on number 2. I don't know all of the factors of 285 by heart. Okay, that's not something I had to memorize in 4th grade or whenever you learn factors. Okay, so I'm going to take my calculator and I'm going to take 285 and I'm just going to start dividing it by numbers. Okay, I'm going to start small and get bigger. So divide it by 2, 3, 4, 5, 6. You've got to get whole numbers out in order for this to work. So if you get a decimal, that means that number was not a factor. Okay, and you just keep going until you get two whole numbers. And then see, do those two things add to get to 4? And if they do, those are your factors. Negative 15 and positive 19. Good. Quick on the draw. All right, so you just keep going until you get those whole numbers. You don't have to write down all the factors. Just keep pressing them in your calculator until you get two that work. Okay? One little thing though. Do you think it matters if I put the 19 on the other side and the negative 15 on the opposite? No, it's not going to matter. Okay? Multiplication goes anyway. Go ahead and try 3 and 4. Okay, number 3. Two things that multiply to 133 that will add to negative 12. Or multiply to negative 133, add to negative 12. What do we think? Negative 19 and 7. Who agrees? Anybody get anything different? Okay, cool. I'm glad you agree. You're right. Number 4. 19 and 8, both positive. Who agrees? Anybody get anything different? Cool. All right. Any questions on this? Okay, now it's time to throw this all together. What is the X method and why are we using it? Here we go. Okay. These are what we call a trinomial. So we've dealt with binomials when we had two terms, okay? And we just so happened to deal with the ones that had a power of 2. So this time we're going to have a trinomial. What a trinomial is just 3 terms. Do we see that this has 3 terms? Okay, cool. So this is what we're going to factor. And here are the steps on how to do it. So you got 3 terms. First things first, always, always, always. GCF. So pull out any GCF or a common variable, which is still considered the GCF, but we'll write it anyways. So always, always, always start with that. Looking at this example that we're going to walk through, do 3x squared, negative 16x, and 5 have anything in common? No. So we're good to go. We don't have to pull out a GCF on that step. We'll skip it. Step 2. You are going to take the first term, technically the first coefficient, times the last term, or the last coefficient. So my first term, 3x squared, I'm going to take that 3, and I'm going to multiply it by my last term, which is just 5. What is that? 15. So I want to find 2 numbers that multiply to give me 15, but I want them to add to my middle term. What's my middle term on this one? Negative 16. So here's my x. Here's what I'm doing. Draw your x. 3 times 5 we said was 15. That's our multiply number. And then we said our middle term is negative 16. So that's the first thing I do. Now I start playing with my calculator and trying to figure out the factors on this one. Yep, so negative 15 and negative 1. Negative 15 and negative 1. They multiply to be a positive 15. They add to be a negative 16. Questions on that? How we did that? Okay. Next thing. Using those 2 new numbers that we found, we now just have a new middle term. And it's actually just going to be those 2 terms together. So here's what I'm going to do. I'm keeping my original first term. What was it? 3x squared. So leave that alone. But now instead of negative 16x, I now have these 2 as my middle term. So I now have negative 15x and negative 1x, or just negative x. My last term stays the same. What is it? Plus 5. So this is my new equation. Does that look like something I already know how to factor? Yeah, and what is that called? Grouping. Yep. I can group that. And then that'll be my answer. So through grouping, we're going to go ahead and solve that. I just want to group my first 2 terms. Group my second 2 terms. So negative x plus 5 or negative 1x. It doesn't matter. Okay. Looking at the first 2 terms, so 3x squared and negative 15x, what do those have in common? 3 and x, good. When I pull out that 3x, my first term becomes just x. And what about the next one? Minus 5. Okay, the next set of parentheses, what do these have in common? 1, but what do we say about if the front term was negative? Negative 1 is what we're going to want to pull out. Okay, so I'm going to pull out a negative 1, and what's going to be left? X minus 5. Do these match? Yup, we're golden. Okay, Last step is just to write our answer. What is that going to be?
3x minus 1.
Perfect. That's it. That is all. Questions on that? Okay. We'll do another one. We will do this one together. Okay, so starting with example 1 here. First thing I always do is check for a GCF. So 8, -40, and 50. Is there anything that I can pull out of all of those? 2. Anything bigger than 2? Nope. Nothing bigger. Make sure you try, okay? But 2 is actually going to be the biggest thing. When I divide everything by 2, what's going to be left? 8x. Good. Good. Is everybody good on how we did that? How we pulled out that GCF? Okay. Am I left with a trinomial? So I need to use the X method. Cool. Okay, so let's go ahead and do that. I'm going to go ahead, draw my X. My top number is my multiply number, which means I'm multiplying 4 times 25. What is that? 100. Keep my middle term at the bottom, which is -20. And there you go. 2 numbers that will multiply to 100 that are going to add to give me -20. Go ahead and try that. -10 and -10. Yep. Okay. So this one is going to work just like the other one, except for we do have this GCF. Don't distribute it. Don't do anything. It's just out here chilling. Okay? But make sure you don't forget about it. So I'm going to leave the 2 out there chilling. Keep my same first term. My new middle terms are going to be what? Good. And my final term? Plus 25. Anybody lost so far? Okay. So now that I have 4 terms, I need to use grouping. Good. What should I group?
4x squared minus 10x parentheses, -10x plus 25.
Perfect. Don't forget about 2. He's just chilling out front. Okay. GCFs. First set of parentheses. What is it? 2x. What's going to be left? 2x minus 5. Next set. -5. And what's going to be left?
2x minus 5.
Do they match? Yep. Good. Okay. Don't forget about 2. He's out here chilling. And now my final answer.
2 2x minus 5.
Good. That is your final answer. It is totally okay to leave it like that. The only other thing that you could do on this one is that you realize that 2x minus 5 was written twice, so you could write it like that, but I don't expect you to do that. I'm totally okay with you just writing your answer the way I boxed it in. Okay? Questions on that? All right, I want you to go ahead and do example 2 and example 3. First glance, though, at example 2, does it look like they have a GCF? No, but what did we say about that front term? It cannot be negative. So what is the GCF going to actually be? -1. Pull out a -1 first. Okay? So do that for 2. Go ahead and do 2 and 3. So So we start by pulling it out the negative 1, and what does this become? Good. Everything just changed signs. Is everybody with me? Okay. Now, we can draw our x. In the top, what do I put? Negative 56, and in the bottom? 1, because it's just a 1x. So I need two numbers that will multiply to give me negative 56, but add to give me a positive 1. And what are they?
Negative 8 and 7.
Negative 8 and 7. Okay. I'll write them down. I agree with the digits. But is that going to add to be a positive 1?
It should be a negative one, right? It's negative on the...
Negative 7.
Negative 7.
So it should not be
So whenever we
negative.
pulled out that negative 1, this became positive. So this is what we're factoring right now, is what's inside the parentheses.
Okay.
Yep, you're good. So everybody with me, 8 and negative 7?
Yeah.
Okay. Now what?
And then put it back in the across. So it's negative 2x squared plus 8x minus 7x.
Yep. So you're just plugging it back in. This is the part we're factoring now, okay? So we keep this a positive 2x squared and a negative 28. Put in our new middle terms. Okay? Now we just do what? Group it. So keep your negative 1 out here chilling. Group your first two terms. Group your next two terms. If you switch the 8x and the negative 7x, it's not going to matter. You're still going to get the same answer, so you're still good. Okay? What can I pull out of 2x squared and 8x? 2x. What's going to be left? X plus 4. And what about negative 7x and negative 28? Negative 7, and what's going to be left? X plus 4. Good. Don't forget about negative 1 out here. Now we rewrite. Negative 1. Perfect. Raise your hand if you got that one. Cool. If you did not, please make sure you know what you did. Any questions on this? Is anybody like, holy cow, what the heck is going on? No one's crying? Okay. Number 3. Uno, dos, tres. First things first. Do we have one? 4. Cool. We'll pull out the 4. What's going to be left? Perfect. Now what? X method. Top number? 20, because 1 times 20 is 20. Bottom number? Negative 9, because that's my middle term. Two numbers that are going to multiply to 20 and add to negative 9. Negative 5 and negative 4. Perfection. So my new problem is going to be 4 times perfect. Then we group. So leave 4 out here hanging out. C squared minus 5c plus negative 4c plus 20. You with me? What do c squared and negative 5c have in common? It's just c. What's going to be left? Okay, and what do negative 4c and 20 have in common? Yep, we're going to pull out a negative 4, and what's going to be left? Do they match? Yep. so I did it right. Cool. Leave 4 just hanging out there, and now we can rewrite. 4 times. Yep. C minus 4, C minus 5, or you could have them, yeah. No, don't erase, Emily, you're good. You can have 4 times C minus 5 times C minus 4. It's the same thing. Doesn't matter what order.
Do we, like, have to show our limit on that one?
Like you did it in your head?
Kind of, yeah. Well,
Yeah.
Mr. Miller said, like, whatever, like, the first
Uh-huh.
word doesn't have, like, a number or anything.
Yep.
Put it in, like CG.
Yeah.
Something like that.
For sure. It is easier on those ones to do that way, but the X method will work on all of them. So that's why we're teaching it that way. But yeah, if you have a simpler way and you're getting the right answer, you're good. Okay, so the rest of that numbers document is homework, okay? And that is just practicing what we just did. Just those trinomial problems, okay? However, we are not done yet today. We still have 2 more short methods that we've got to learn. And then after this, your homework for these methods is just going to be 10 Delta Math problems. So pretty laid back day, just finishing that numbers doc, and then 10 Delta Math problems. But we do have to learn this real quick, okay? Everybody good? Cool. Factoring by sum and difference of cubes. So when using sum and difference of cubes, first make sure that you have a binomial, which just means 2 terms, binomial, in which both values can be cube rooted, okay? And how these work. So the first one, I'm gonna give you just the formula. So when you see a to the third plus b to the third, do you think that's a sum or a difference of cubes? Sum, why?
The
Plus sign gives it away. If it's a plus sign, that's a sum of cubes. And here's how it looks. Just write this down. Don't freak out. A plus b in one set of parentheses times a squared minus ab plus b squared. Don't freak out. It's going to be okay. So when I look at this example, I've got x to the third plus 8. Is x to the third something that I can cube root? Can I cube root this? And what is it going to give me? Just x. Okay, so that's my first term. So a is just going to be x. Can I cube root a and get a whole number? Or 8, sorry, not a. Can I cube root 8 and get a whole number? It's just 2. Are we all familiar with how to type that into our calculator? How to find a cube root? Okay, so b is going to be 2. The cube root of 8 is 2. So how I write this? A plus b, so just x plus 2. A squared is just going to be x squared. Negative ab, so a times b is just 2x, negative 2x. And then b squared is just going to be 4. 2 times 2 is 4. And that's your answer. That's it. That is all. Okay? So that is a sum of cubes, and we are going to practice it. You're going to be okay. Difference of cubes. What's different about that? Yep, subtraction sign, okay? The difference of 2 numbers, we know we use a subtraction sign. So this is just the notation for difference of cubes. It's going to be almost identical to that, but there's going to be 2 little changes. Instead of a plus b out front, it's going to be a minus b. Keep the a squared, but instead of a negative ab, it's going to be a positive ab. And keep b squared. So there are 2 things that change. So if you start out and it's a sum of cubes, so a plus sign, you start with a plus sign, and then in your second set of parentheses, your middle term is negative. The opposite exists in difference of cubes. You start with a negative sign, and then your middle term is going to end up being positive. So it's just recognizing that, okay? X to the third and 27, are those both numbers I can cube? Yup. So A is just going to be X, and what's B going to be? Cube root of 27. 3. So I would just write X minus 3, because A minus B. A squared is just going to be X squared. What's A times B? 3X. And B squared. 9. That's it. That is all, folks. Questions? Okay, let's do some examples. Woohoo! I'm gonna do the first one with you. Looking at this one. 8x cubed plus 64. Always, always, always. We start with GCF. GCF. Do these have a GCF?
Yes.
What is it? 8. So I'm going to pull out the 8. What's going to be left?
X to the third plus 8.
Okay. 8 times x to the third plus 8. Are x to the third and 8 both things that I can cube root?
Yes.
Yup. Okay, so go ahead and try that one. Okay, what's a going to be? X. And what's b going to be? 2, and it's a sum or a difference? Sum. Okay, so I'm going to leave my GCF out here hanging out. My first set of parentheses is going to be x plus 2. My second set, x squared plus 4. Good. So this middle term is always just going to be these two numbers multiplied by each other and then change the sign. Okay? We all see that? Cool. Number 2. Go ahead and try. Actually, we're going to do this one together. Does this one have a GCF?
Yeah. Maybe?
I don't think so. Nope, it doesn't. But are these both terms that I can cube root? Can 64 be cube rooted?
Yes.
Yeah, and 1 can be cube rooted, right? Yeah. So what is 64 cube rooted?
No, 8, sorry. Wait.
4. Yep, it's 4. So the cube root of 64x to the third, would you agree with me that it is just 4x? And then the cube root of 1? 1. And this is a sum or a difference? Difference. So I'll start off. A minus B. 4x minus 1. Okay, so 4x minus 1. Then we need a squared, which is going to be... What's 4 squared? 16x squared. Okay, then we got plus AB, right? What's that going to be? Plus 4x plus 1. That's it. Questions on that? No? Anybody? Okay. I want you to go ahead and try 3, 4, and 5. We'll go over them in about 5 minutes, and then I'll give you the rest of the time to do your homework. Number 3, numero trace. GCF, what is it? 8x. Pull that out first. Then what's left? Plus 1. Okay. What now? Say what? A equals 2x. Good, because that is the cube root of this first term. You all right? Hope you got a screen protector on that.
Oh, I cracked a little more. That's alright.
Oh, bummer. What's B gonna be?
4.
1. Cool. So we leave our GCF outside. Our first set of parentheses is going to have what? 2x plus 1 because it's a sum. Then what? 4x squared minus 2x plus 1. Great job. That's it. Questions? Cool. Number 4. GCF. What we got going here? What do both of these numbers, 48 and negative 243, what do they have in common? A 3. Whoops. Yep, they do have what else? Y squared, good. And what's going to be left? 16x squared minus 81. Is that what you said? Okay. That's how far you got. Okay. What is this? A binomial. And what's the exponent on it? It's a 2. So is this a cube or a square? Square. Is it a difference of squares? How do you know that? It's got a subtraction sign. It's got the exponent of 2. And what else? Yep, these are perfect squares. 16 and 81 are perfect squares, right? Yeah. Anybody remember how to do these? Just did one in the warm-up. Perfect. 4x plus 9, 4x minus 9. And keep your GCF outside. That's all. Questions on that one? Tricked ya. You thought it was going to be a cube.
Yeah,
It wasn't.
Yeah, it's not a cube. Maybe you were throwing a new rule at us. And was
Nope, just trying to make you remember the old one. Liz looks like she might pass out. You okay? Cry a little bit? Okay, don't cry a lot.
I mean, a little bit's good for your skin, but like
It is.
irritation.
Like a good shower cry, like I feel like that's good for the soul. It's good for the soul. Blake, do you ever just have a good shower cry?
You have to make sure it's dark too.
I've not had a shower cry before.
Okay, you should try
Make
it.
sure it's dark too.
Do it. It's for
Is it nice?
Okay, example 5. 1,000 m to the third minus 125 n to the third. What they got in common? They do have a 5, but they might have something bigger. You guys haven't even checked this one. Like, they do have 25, but it's a little bit more. I'm going to give you a little more time on this one. I'm pausing the video. Andrew, say it a little louder. 125 goes into both of these. Oh, I didn't hear you. 125. And when I pull out a 125, can I pull out a variable? No, because they don't have the same variable. But when I pull out a 125, what's left in the first term?
an 8.
8? Is that right? Okay.
What is it?
And what about negative 125 n to the third divided by 125?
Negative n to the third.
Okay, cool. Can I factor the inside further? What we got going on? Squares or cubes? Cubes, so difference or sum? Difference. Are 8 and 1 perfect cubes?
Yes.
Yeah. So can I do this?
Yep.
Uh-huh.
So, it'd be 2 minus and plus.
Hold on. What is A going to be?
2 minus
A is going to be 2 this whole term. Cube. Yep. 2m. And B is going to be
negative n.
just 1n, right?
Yeah, just 1.
We're just in. Not for these, just because it's difference already? Okay. If you did call it a -1, then you'd have to perform the sum of cubes, okay? Because you'd technically be adding a -1. But since we're just subtracting a 1, that's why we're using difference of cubes. Does that make sense? Okay. So now, A is
2m cubed.
nope, just 2m
Two M.
Just 2m,
But we just,
minus n.
and then 2m plus n.
No.
What?
A squared. 4m squared.
oh yeah.
Plus n squared.
What?
No, we're making
Minus
two
N squared.
M.
What's the middle term?
Plus 4m.
No.
Wait, 2m. So a and b.
Oh, it's
Two.
2n.
Yeah.
No, 2m and
You need to talk louder. What's the last term? Plus.
N squared.
Thank you.
TJ, you're saying plus, dude. That's not minus. It's not right. I said
That's our
I said
answer.
plus n squared.
Dude.
Now I'm gonna go home and have a shower cry just because of you guys.
Are you supposed to square the 9 too, so just be 1?
Square the 9.
I mean the n.
Whoa.
The 9.
What?
Never mind.
I don't know what you're saying. The n?
TJ.
We did square the n. That's what's at the end. That's b squared.
Yes.
Yes?
Okay.
Yes.
Okay. Any other questions? Are we okay? Are we cool? Okay, start on your homework.